Hello everyone, greetings to one and all. In our today's episode of our SAP technical series, we'll be seeing the fifth set of syntaxes that are available in our ABAP and HANA platform. So previously we have already seen four set of syntaxes which are present as part of the previous videos. I highly recommend you go through the previous videos of the same series and also the other videos of my other series for a better understanding of the concepts of ABAP and ABAP and HANA. So in today's episode, we'll be seeing about string and embedded operations. So these are the three new syntaxes that we are going to deal with: chaining operator, string templates, and embedded expressions. Without wasting any further time, let me get on to the demo part. So I have written a small sample program for you wherein I'm dealing with a local class and I have written one method, local method for each of this: chaining operator, string template, and embedded functions. So let me directly hit on the program and I'll explain in the debugging mode. So if you see here, we have four different variables. I'm concatenating all these variables from 1 to 4 into variable 5. How am I doing that? It's simply with just this AND operator. So this usage of this AND operator is called as a chaining operator, wherein all these values are just concatenated into the final variable. So if I show the final variable now, they don't hold any value. Whereas if I check on LV1, LV2, LV3, and LV4, you see all the values already stored there. Now I execute the statement and complete all the characters, I mean all the variables get concatenated into a single variable. Okay, so this is a proper example of a chaining operator. Now let's move on to the string template. The string template is easier just for assigning any statements or any strings into a particular variable. You just have to use the pipe symbol, and in between that you can incorporate all the data, all the strings that you want to feed on. So if you see lv underscore 1 now doesn't hold any value. Now after execution of this, it holds this value. This is a string template. Now if you watch carefully, there is a gap here. When you use in between a string template, even this gap gets loaded onto the variable. You see here, there is a gap here again. Okay, and in addition to the string variables, you also have the capability of loading variables, actual variables. So here I'm trying to use the system variable size sub rc. If you see lv underscore 2, if you see lv underscore 2, right now it doesn't hold any value. Once I execute this, you see this, the above expression result is 0. So the 0 is actually from the size sub rc value. So this is a typical example for string template. Now we'll move on to the interesting syntaxes called embedded functions. So what does this do? So initially I'm assigning an value to lv underscore matner. This matner has a data type of character 40. So what happens initially, I'm just executing this code so that I don't have to use the function modules anymore for my conversions. Okay. So what does a conversion do? It basically converts the number based upon the internal formatting. Like if it is a 40 character, it will add leading zeros to the existing number. So right now you have 7 digits in this value. So if 47 minus 40, I mean 40 minus 7 is 33, it will add 33 leading zeros to this variable. That's what a conversion function module does. The same will now be performed with the single statement, wherein when you say alpha is equal to in, it will convert into an internal format, and when you say alpha is equal to out, it will convert into an external format, which just removes the leading zeros. Now as a first step, I'm just adding the variable with character 40. You see this data type is character 40. So it just ensures the number whatever has been fed into the variable has in total 40 characters, wherein the leading spaces will be occupied by zeros. You see here. Now, the embedded functions also has a capability of defining the width in dynamic. So here I am defining the width to be just 18. You see what happens now here. The same value will be in 18 characters, wherein the leading spaces will be occupied by zeros, so that the total number of digits in this variable will be 18. Similarly, I can also adjust it to any digit I want. Now I'm adjusting it to 10 digit. Now, take in case of this value, the value of this particular lb underscore value variable is just success in lowercase. I also have the capability to change the cases. Now, for example, it is align. I want it to align to the right, and I want it to be converted into an uppercase. Let's see. You see, now the value is now convert lv underscore value is now declared as uppercase. So it doesn't stop there. We have all these embedded functions that can be used within this particular variable. Like just how I used alpha and width, you can also keep using All these, you can use a sign statement, you can use a case, you can just use the align, width, and then zeros, decimals, time format, date format, number format, so currency format. So all these are available. So whenever next time you want to make use of any of these functionalities, I would recommend you to use this embedded functionalities. Now let's execute and see the final execution. So I'm just writing uh, all the variables that I have calculated for each of this. So we have seen what is a chaining operator, wherein usage of and symbol. What is a string template, wherein you use a pipe symbol, and between you can have your strings, and you can also use your system or local variables dynamically. And in embedded functions, it is a replacement for your conversion factors, and it also has many other embedded functions like sign functionalities, case statements, with etc stuffs. So I hope in today's session you have seen some important syntaxes that will be very much handy when you are doing your day-to-day programming. So thank you all for the time. I'll see you soon with my next key technical concepts. Until then, take care, peace and blessings to everyone.